For this video, we're going to try to understand frequency filters. So take a look. This is a program called GarageBand. It comes free with most Mac computers, and it has built in this awesome visual equalizer, which allows us to really explore this crazy concept in a really cool way. One of the cool pieces of it is that it has built in, well, let me just show you here, right? This has frequency on the horizontal axis. You see it goes from 20 hertz up to 20,000 hertz. It's also marked as bass, low mid, high mid, and treble. So this should remind you of like those tuning dials on your radio where you can tune up the treble or up the bass, and you can in a sense filter the sound. Okay, it also, this is what makes it so cool, it also has this analyzer. So I can see the frequency spectrum of my voice as I'm speaking. Just like we saw before, but this is super cool. Alright, so if I made a pure tone like I whistled, you should be able to see a single frequency appear on this analyzer. Alright, really cool. Now, I can customize this filter. This blue line represents a frequency filter. Right now it's not changing any of the frequencies. So what you hear is the sound that's actually coming out of my mouth. But as I filter this sound and change it different ways, you'll hear how my voice changes. So let's start with the four kinds of filters that were discussed in our reading. There is a low pass filter. A low pass means it's passing the lower frequencies, which means it must be kind of cutting off the higher frequencies. So I can simulate that here. I can do that by turning down the filter here on the high frequencies. It's kind of like tuning down the treble on your car radio, and you hear how my voice sounds different. You also see now that the frequency spectrum of my voice looks different than it did before. So check it out. I mean, this is crazy. It's like, look at the spectrum. The white line is my original voice spectrum, but then when we multiply it by a filter, you get a new spectrum, right? Crazy. Okay, so that's the low pass filter. Let's check out a high pass filter. For high pass, it means I'm cutting off the bass frequencies, and so my voice is going to have this different kind of tinny sound to it. And you see once again that now the spectrum has been changed. I took the source, multiplied it by this filter, and now I get a new spectrum. Okay, cool. Now there's two other kinds of filters. One we call a band stop filter. So the idea there is a band, when we talk about this, really just means a range of frequencies. So let's just say from 500 hertz to 1,000 hertz, that represents a frequency band. So let's try to stop that band. There, roughly, between 500 and 1,000 hertz, I'm kind of stopping that band. Now that is not really easy to notice, but if I tried to whistle that note, check this out. Okay, let me whistle roughly 1,500 hertz. Now let me filter that band, and I'll keep whistling while I'm doing it. So you can see I'm kind of like selecting out a particular sound. All right, the last type of filter mentioned in the book is a band pass filter. That's a case where we would filter out everything except a particular band. So let's try to filter out everything except from 500 to 2,000, let's say. So I might go down over here, and I'm talking still, but now I've filtered out the low stuff, and now I'm going to filter out the really high stuff, and now I'm only letting through the sound in that particular band. Alright, so that would be the band pass. Now, we get one step more complicated when we talk about resonators, because resonators are effectively frequency filters. And that's the case because they only resonate at specific frequencies. So check this out. I have a wine glass in front of me, all right? And I'm going to talk normally, and then I'm going to put my mouth inside the wine glass and talk. And what I want you to notice is how the frequency spectrum, the white line, changes when my mouth is in the glass versus not. All right? So check this out. I'm going to talk now with my voice outside of the wine glass, and then I put my voice inside the wine glass and talk at the same volume. Now what I notice is that when it's in the wine glass, there's a bump that goes up, like a boost that happens right here, a little resonant boost, and then there's a little drop that happens right here. Okay, so watch again as I do this. Now I'm talking without my voice in the wine glass, and now my voice is in the wine glass, and you can hopefully see what I'm talking about. Okay, so I can recreate this. I mean, effectively, what the wine glass is doing is causing a little boost right here, which I can simulate with this filter, and it's causing a little drop right here, which I can also simulate. So now, there's no wine glass involved, but I'm approximately simulating with this filter the kind of resonant pattern that happens when I speak through the wine glass. Now you can imagine, whoa, this sounds weird, let me get rid of it. You can imagine the same thing happens to the sounds that are generated inside our body as they pass through the vocal tract. The vocal tract resonates in all sorts of different ways, and we change how it resonates. So we're constantly changing this filter of our vocal tract. In fact, as I talk, you see it's changing a lot. All right, we're constantly changing that. And so the source sound is being, which might not have much variation in it, is being dramatically changed through the changing filter, which is our vocal tract. Cool. I hope you thought this was as awesome as I think it is. And if you have GarageBand, you should play with this on your own.